So if you've logged into the website, you'll notice there's a new card there. So we're going to continue on with React, not surprisingly. And today our kind of focus is on how we can make components dynamic. Up to now, they've been static. So let's see how that's going to work first. Okay, so again, people can see my slides and they can hear me. Isn't that right?
Yeah.
Great. So as I said, the agenda really is all about making our React components dynamic. By that I mean that the user can interact with the component, and as a result of that interaction, the component may anyway change what it displays on the screen. That's really what we mean by a dynamic component. It may do other things as well as a result of the reaction. It may actually make a web API call, and we'll see how to do that. As well, we know from at the very end of the last lecture, I made this kind of big statement, which was that every React app that you ever develop is always going to finish up as a hierarchy of components. And we need to talk a little bit about how data flows through that hierarchy. It's actually quite restrictive in terms of how data can flow through it, but that restriction is a good thing as it turns out. And again, it was one of these other kind of conscious decisions that the design team made. Thirdly, then we're going to kind of loop back and forth between these two topics, and certainly the two, the second and third topic. We're going to talk about something called hooks, and then we'll go back and talk about data flow again. Hooks are they're pretty central to the React component model, and they were only something that were introduced 2 years ago, 2019. Yeah, 2 years ago, February 2019, they were introduced into the React framework. Now, what preceded them, you could still do everything that you can do now with React components. You could do it in the kind of pre-hook time, but your programming model was actually different. I'll briefly explain what I mean by that. So the first thing there is component state. And to move a little bit higher up, but I want to talk about component data. So it turns out that a component can have two sources of data. One we've already seen, which is props. Props, we know, is data that we pass into a component from the outside. And we also said that prop data is immutable. Component cannot change it. And it accesses its props by means of a special object called the props object. That's fine. That's props. That's one source of data. The second source of data for a component is kind of everything that props isn't. The second source of data is what we call state. State is data that is managed internally by a component, so it's kind of private to it. It is mutable or changeable. That's very important. And in fact, that mutation is what is central to making a component dynamic, because it turns out if we change a component, well, not if we change, if a component changes its state, then that will cause the component to automatically re-render or re-display itself. And between any two re-renderings, it may actually change what it wants to display onto the screen. So it is the basis for making components dynamic, this notion of state. Just going back to props for a second, there's one or two little aspects of props that I didn't cover last week. I'm just covering them here for completeness. One is, we know that props are passed into a component, but what if you actually call a component and you don't provide one of the props that it expects? Then is it possible to define a default value for a prop? And the answer is yes, it is. And secondly, what if you pass in a prop that's of the wrong type? maybe it's expecting an integer and you pass in a string. Is there any way that you can programmatically do some type checking? And again, the answer to that is yes. So I will show you how to program those two aspects of props. To be quite honest, I don't use them myself, and you don't see them used very often. Maybe that's just because we are only programming for fun, really. We're not actually programming production systems. So in a production environment, these aspects would be important. In relation to state, which is really what I want to focus in on, state, we want to be able to initialize state somehow. We want to be able to programmatically initialize state because it is internal, but we want to give state some meaningful initial value. Otherwise, it's going to be undefined, and that's not desirable in most cases. And because state is quite a special aspect of a component, it's not just like ordinary local data. It is quite special. So the way we will actually declare a variable, even though it is local to a component, the way we will declare it is going to be slightly different. And the way we mutate it or change it is going to be slightly different, in the sense that we will need a special method to do that. And when we talk about changing the state, a state variable of a component, because a component could have many state variables, and a state variable can be of any type. It could be an object, an array, it could be anything as complex as you want it to be. But when we talk about mutating a state variable, we're essentially talking about an overwrite operation. It's not a kind of an increment or update operation. And as I've already alluded to, changing a component's state variable will cause that component to automatically re-render or re-display itself. That the React framework takes care of that. We don't have to do that. That's actually built into the framework. That's kind of the contract between our code and the React framework. Let's start with example 101. So what I'm showing you there on the right is I've got this component, which I've called a counter, and its internal state consists of an integer. That's what count is there. So that's my state variable for this counter component. And what I'm also showing you here is that the component expects a prop. Sorry, no. It expects a prop of type integer as well, and I've just called the prop jump. And what the component does, nothing too exciting, it takes the jump value and it increments the state variable by the jump value every time the user clicks a particular button that is associated with the component, right? But and the component is going to also display its current counter value. So rather than talking about it, if we just see it in action. So even though the code is quite small now for this, I am providing the code in the archive with this week's lecture. So here's what you need to do is you need to import this counter component, although I've called it state here. You need to import the component file into your basic React lab from 2 weeks ago. And there's also a couple of stories that you need to add to these stories. And I give you the stories code. So you just add that to your stories file and away you go. And so if we start up our storybook server, so the only one we're interested in now is this one down here. Now, as it turns out, I've defined 3 different stories for it, but I'll explain that in a second. So if we look at the normal one, I suppose. So here's what the component renders, and it has a button, so I can interact with it. And every time I click the button, it increments the counter by this value. But the component is dynamic in the sense that it is changing as a result of the user interacting with it. So it's got that fundamental dynamic aspect to it. Right, so will we look at the code, I suppose, is the next. Did I want to say anything else in the? Right, yeah. Okay, so how do we declare our state variable, and how do we mutate it? And it's all via this special function called useState. Let's actually look at the code, maybe that makes more sense. So here's my code. And really, there's only one part that's kind of new. The rest is not that new. Forget about this part for a second. And forget about this part for a second. I've got a console.log. I've got a local little function. That's okay. And here's what the component displays, which we'll see. So the component has a button, and here's the button here. And the button has a on-click handler. And I'm associating the on-click handler of the on-click property with a local little function, which is this function up here. So every time the user clicks the button, this function executes, right? Now, the key line though in relation to state anyway, the key line in this component is this line here. This is how we declare a state variable. So there's a special function which is provided by the React framework. You can see I'm importing it here, called useState. And you pass useState the initial value of the state variable. So I'm passing it 0. So that tells me that this state variable is going to be an integer type state variable. The initial value obviously dictates what type of state variable it is. So it's going to be an integer. What useState returns is an array. And there are two elements in that array. The first element is a reference to the actual state variable itself. The second element of the array is a function that will allow us to mutate the state variable value. You may not have seen this kind of syntax before, but really all that's going on here is, as I said, useState returns an array with exactly two elements. And we can actually access those two elements using this syntax here. It's using something called destructuring, which is a JavaScript thing. I'll cover it maybe formally next week because it's something that we use quite a lot. But I mean, we could have went the long-handed way, right? The long-handed way would have been to do this. Okay, I won't give it any meaningful name. I'll just go foo. So foo is an array, and I could then go on the next line, const count. I call it count equal to foo subscript 0. On the next line, I could go const set count equals foo subscript 1. Okay, so those three lines, I could have put those three lines, and they would essentially be doing the same as this up here. Okay, but obviously, the way I've done it is more, it's kind of a shorthand, I guess, if you like. It's got nothing to do with React now, it's just a JavaScript thing. So I have a reference to the state variable, and I have a reference to a function that will allow me to change the state variable. The initial value for this variable here is going to be dictated by whatever I've passed to useState. So it's going to be 0. So when this component renders, this is going to be 0. This is going to be referring to a function. And so in terms of what the component renders initially, it's going to render 0 here. And that's what we saw. Let's go back to here. I'll just reload it. Right, that's what we saw. When I click the button, the on-click event handler runs. The on-click event handler is this little function here. And lo and behold, it calls the mutator or setter function for changing our state variable. And I'm just simply taking the current value of count. I'm adding props.jump because jump is passed into my component, as I said in the kind of specification. Just adding those two together, and that becomes a new value for my state variable. Now, Critically though, as well as the state variable changing its value, this is the really important point now, as well as that, what also happens is the counter component re-executes from beginning to end again. In other words, what we say is it re-renders. And so now count is going to have a value of whatever, let's say 3. Let's say props.jump is 3. It's going to have a value of 3. And so count is now going to be 3 here. Yeah, that's what we saw when we clicked it. We're incrementing by 3. If I click it again, the event handler the onClick event handler runs again, changes the state variable, bumps it up to 6. But having bumped it up to 6, having changed the state variable, the component re-renders all over again. And so that's why this is constantly changing here. Right. Simple enough as it is. Is there any question about that, I wonder? No. When I say the component re-renders, so the message is every time you change a state variable, the component re-renders. What do I mean by re-render? I mean it executes from beginning to end. And I can prove to you that it executes from beginning to end. It's not just that the return part executes, the entire component function re-executes. And I can prove that because I've put a console.log here. And if I open up the developer tools, I'll refresh this all over again. If I open up the developer tools and watch what's going to be happening over here, every time I click, then this stuff is coming from the console.log. So it must be that the entire component function is re-executing.
Sorry.
Yep.
I wanted to ask, does that not create like a flashing effect in some sort of components?
Well, if there was
quite a lot.
Sorry?
If you're updating quite a lot, like a chart on a stock market chart or something, it will create a flashing effect.
Well, possibly. I mean, what React does is it looks at what needs to change in the UI. It carries out those changes to the DOM. You remember the DOM data structure that Frank told you about? It carries out those changes to the DOM. And, you know, if there is going to be a flashing effect, that's just a browser thing. We can't stop the browser from doing that. Other than trying to make the updates to the DOM to try and minimize the flashing effect, then we would try and minimize the amount of updating that we have to do to the DOM. React takes care of that for us. That was one of the good things about React. Its performance in terms of DOM updating was much better than its competitors at the time. So, like, the flashing effect is really a browser thing rather than a React thing. That's probably not a very satisfactory answer, but what was neat, what was kind of novel about React when it came out is that it significantly improved the performance of your DOM updates and hence your screen updates. So whatever flashing effect you get from React, it would have been more pronounced using any of the other single page app frameworks, and much more pronounced if it was just raw JavaScript code that you were writing. Because at the end of the day, when I talk about a component being dynamic and the component re-rendering, the re-rendering really means that we need to make changes to the browser's current DOM data structure. And as we know from Frank spoke to you about that, whenever a browser's DOM data structure is changed, what the browser will do is it will reflect that change in what it paints onto the screen.
Yeah.
So
I think it will be very good at not having a flashing effect. Okay.
Yeah, I mean, there was one topic that I was going to cover this week, but I've taken it out and I'm going to cover it next week, called the virtual DOM. The virtual DOM is something that React brought into the whole single page app framework space, which none of the other frameworks had at the time. A number of frameworks now use this virtual DOM idea. I'll talk about it next week. I'll only briefly outline what it's about. It's one of these things that's kind of in the background, but the main benefit of this virtual DOM construct that React utilizes is to improve what I'm calling the performance of your web app. And by performance, one aspect of that is how quickly it actually updates the screen, and also to try and minimize that kind of flashing or staggered or latency kind of experience that you might have. Okay, so this use state function is what we use to declare a state variable. And when I said there that the component re-renders, and re-rendering means it executes from beginning to end, like if you think about it, right, if that's the case, then when the component renders for the second time, this function is called. Now you might say, well, surely should it not reinitialize the state variable back to 0 again? Because that looks like what we're doing here. The first time the useState function executed, I said that it initializes the state variable to 0. But the second time it executes, the second time the component re-renders, it's the exact same function call that's being made, but magically it's not resetting the state variable back to 0. So there is something special about the way this function is implemented, which I'm not going to go into. It uses something called closures. You can Google it and find out exactly, maybe, although you don't need to, how it actually achieves that special kind of behavior, which is that when the component re-renders multiple times, it somehow seems to be ignoring the initial value on the second and subsequent renderings. So in other words, count in my case is always going to have the correct value. The setter function that's returned is always going to be the same. And the other thing I would say, and I will leave it at this now, is that I'm saying the state variable is local to the component, but it's actually being managed by the React framework itself. This count variable here is not just like any other ordinary variable. Like if I declare an ordinary variable here, that x equals whatever, there's a big difference between the x variable and the count variable. Right. One or two other things in passing down here. This is how we give default values to props. So the syntax isn't great, but there you are anyway. So it's quite a long-winded syntax. So this is essentially initializing, or sorry, it's giving a default value of 2 to my jump prop if none is specified. What's going on down here, you could kind of guess. This is how we programmatically declare what type of thing the jump prop is. And we're using a third-party library, which I'm importing up here to do that for us. So it's quite expressive, this prototype, or sorry, this prop types library. It would allow us to express the default value for a more complex prop. Prop here is just an int, or jump prop is just an integer. But if we had a more complex prop, then we could express, if you had a prop that was an array of objects where the elements in the object, the key value pairs in the object had to be strings, let's say, you could express that using this prop type syntax, which you can look up if you'd like. Okay. Just to show you the stories, actually, I have 3 stories. If I go into them. Here are my stories. And the first one you can see here, I'm not giving it any jump prop. So that's where the default kicks in, and based on my code, I think I defined the default to be 2. So that's what is happening in this story here. And again, it behaves as before. The third story is kind of exercising my type checking. You can see here I'm passing in a jump prop, which is actually a string. Now, all you will get from the type checking, if I refresh this, and if you watch what happens over here, when I try and trigger the error case, which is the one that's passing in high as a prop, then what the props type will do is it will just report a warning message to the console. So it's more for developer, really. So that's why you should always have your developer tools open when you're doing any kind of web development. I've mentioned that before. Like the behavior isn't what you'd expect. The behavior is actually going to be like this. Okay, so that's the prop type library isn't really going to do anything to try and prevent the component from re-rendering and trying to execute its behavior. But clearly that behavior is not what you wanted. So all you will get from the prop type in terms of default checking the types of your props is you get these kind of warning messages if you try and use a component incorrectly in terms of passing in incorrect props. Right, so this useState function, it's for declaring state variables. It provides a setter or mutator method, and you can call the mutator anything you want to. It doesn't have to be called set something as I did there, but we're familiar with the kind of setter and getter methods from other programming languages, but you can call it anything you want to. Technically, we would say that the useState function is what's called a React hook, which I'll come back to in more detail later on. The props type, just from a JavaScript syntax point of view, what we're actually using there is JavaScript static function declarations. That syntax isn't very, it's not very neat really, but that's what they are. Like we're calling, it looks like here, we're calling a property on our function, okay, which looks unusual, but this is essentially a static function associated with our component. Now in passing there, we came across React's event system, which is really only built on top of the browser's event system. As you know from the lecture with Frank, a browser is essentially an event-driven programming environment. By that we mean any interaction that the user has with the current web page that causes the browser to, as we say, fire events or to trigger events. And we can associate a piece of code, a function, with the occurrence of an event, and we can get that function to do whatever we want it to do. So when we clicked the button, we associated a function with the clicking of the button. We would call that function an event handler, a non-click event handler. And so that's part of what the browser is, and React just builds on that. All I'm saying to you here is that what React does is it provides a wrapper for the native event object that the browser creates, because the nature of the event object that a browser creates can vary from browser to browser. And so what React does is it wraps the browser's native event type and provides a generic event to your code, which technically the event is of type this here, syntactic event. I didn't use the event. If we look at my code, I didn't actually use the event in my event handler. This is my event handler here, and I didn't use the event at all, but there is a default parameter for the event handler, and you can call it anything you want to. Event would be a sensible thing. Okay, so you can actually access the event object within your handler function, and we will need to do that in some cases. The other thing, the small thing to do to note is that if you've done any kind of browser-based programming and done any kind of event handling in the browser, the React's names for these event handlers are slightly different from the natives. The native event handlers names are like this on click, on change, whereas the React ones are what we call camel cased. Okay, so there's just a slight difference in the naming convention. If you want to get a list of all the possible types of events that you can access within a React app, then you can by all means look up that URL there. So this idea of changing state and component re-rendering, this is central to React. So I'm just documenting here now what I've kind of already said. When the user clicks the button, the onClick event handler executes. Now the onClick event handler can do anything you want it to do. In our case, and in fairness, in most cases, it will change that component's state variable or one of its state variables if it has more than one. And of course, as we now know, if a state variable changes the state variable, if the state variable changes, then this happens automatically. The component re-renders, re-executes. So that's component state. Next thing I want to talk about is data flow patterns within a React app. Now, what I'm trying to get across in this picture here is, so here is a generic representation of a React app. And again, it is a hierarchy of components. Now, first of all, what I mean by this relationship here, I need to explain. This relationship has got nothing to do with inheritance, if you're familiar with inheritance. What this is telling me is that if I looked inside the return statement of this component, in other words, looked at its JSX, then within the JSX, it would contain a reference to this component and this component. That's what I mean by this relationship here. Similarly here. So data flow within a React component is unidirectional, and it's always in a downward direction. And we now know that the way we pass data between components is via props. So props can only flow in a downward direction. Again, that was a conscious decision made by React. Other frameworks at the time supported what is known as two-way data binding, which meant data could flow in both directions. That was a nice feature of other frameworks, but the downside of it was it made debugging quite difficult. So the React team decided that they weren't going to follow this bidirectional approach. They're going to follow this unidirectional approach. Now, the second thing I want to get across in this diagram is I've kind of color coded. So what I'm trying to get across is that any component that has this kind of color in it is stateful. In other words, it has a state variable, one or more. Whereas the ordinary white boxes are components that do not have state. We call them stateless. So I've got this is stateful, and this is stateful. And as I document on the next slide, in the vast majority of cases, the majority of your components within a React app are going to be stateless. Only a small few will be stateful. That's what you should aim for, and really that's what you will finish up with. On another lecture, I will explain how you get to this kind of state of finishing up with a hierarchical component structure. We needn't worry about how we get there, just accept that this is what it's always going to finish up with for any React app. Now, we know that when a component state changes, that component re-renders. But the additional piece of information now is that when this component here, it's stateful, let's supposing its state changes as a result of the user interacting, this component re-renders, but also this component and this component is going to re-render. And this component's child is going to re-render, and this component's children are going to re-render. So when this component at the very top ever experiences a state change, the entire hierarchy of components all re-render. That does sound inefficient, but React has a way of minimalizing the effect of that re-rendering. But for now, just accept it, right? That when a stateful component re-renders, its children also re-render. And even if its children are stateless, when a stateless component re-renders, its children also re-renders. Right, so that's the three kind of messages. There's a fourth message actually I want to get across from this diagram too. So again, let's take the example, this component experiences a state change, so it re-renders. Now, it may be that in the second re-rendering of this component, based on some logic within the component, it's actually going to decide to leave this part out. Okay, in other words, drop this relationship here entirely. So this doesn't re-render at all. And in fact, more than that, what this component actually is removed dynamically from the hierarchy. And so if it's removed, whatever it actually contributed to the UI is also removed from the screen. So that can happen, right? That's not an uncommon thing. In fact, it's a very common thing. So when a component re-renders, it may be that one or more of its children will be removed from the current active the current active component hierarchy. What we say is that this component is unmounted from the hierarchy. And if that's unmounted, then its children are unmounted as well. Maybe later on, this component re-renders again as a result of some state change. And in that re-rendering, this becomes active again. So we now say that this component is remounted onto the hierarchy, and its children are remounted as well. So during the runtime behavior of a React app, components can be detached and reattached to the hierarchy multiple times. We use the term mounting and unmounting. A component and its children can be mounted and unmounted from the component hierarchy dynamically at runtime. Okay, so there's a lot in that. And I'm kind of summarizing it here. And most of those points I've mentioned already, so I'm not going to talk through this text. You can read it over yourself. I'll just pause for a second in case there are any questions on it, because there's a lot really in my explanation of what's going on there. Now, I'll make one final point. This is a stateful component as well. Now, if something causes this component's state to change, it re-renders and its child re-renders. There's no impact on what's above it in the hierarchy. Right? And it's very often the case that the very top components are certainly ones very high up in the hierarchy. It's very common for those to be stateful. So you will get this, what seems inefficient, outcome of when this component re-renders, the entire hierarchy re-renders. But as I said, React has a way of making intelligent decisions about whether it should actually re-render its children or not. You know, quite often maybe the props that are passed are the exact same values as they were before. So as a result of this component re-rendering, let's suppose the props haven't changed since the previous re-rendering, then it wouldn't make sense for this component to re-render at all. And React can make decisions along those lines. Right, that's data flow. Next, I want to talk about hooks. I'm going to come back to data flow though, because I've only talked about it in kind of generic terms. Hooks is the next topic. Hooks were introduced in February 2019. So for a long period of time, React didn't have this notion of hooks, but what hooks can do for you, you could always do with React, we just programmed it differently. What are hooks? Number one, they're just simply functions that come with the framework. And in most cases, they are functions, or in some cases, they are functions that take functions as arguments. So they are higher order functions, which we've come across before. So that's just from a syntax point of view, they're just functions. This is the really important part, though. What is the purpose of these functions? And they allow us to manipulate the state and manage the life cycle of a component. We've already seen one of the hooks that come with the framework, which is use state. That is a hook. And it specifically allows us to manipulate the state. Other hooks affect what I'm calling managing the life cycle, and I'll talk about that a little bit later on. Now, point number 3 isn't really that relevant to E. All I'm saying is that like we always had the notion of state associated with components in React, and we always had this notion of a component's life cycle and being able to manage the life cycle and being able to change the state. That was always possible from day one, but it wasn't using these hook functions. Instead, what we had to do is we had to implement our component as a class, and we had to inherit from a superclass called component. And that superclass had specific methods that we had to override. So it was the kind of classic object-oriented approach towards implementing React components. But we no longer do that really since February 2019. You may still see, you will definitely see implementations of React components that are implemented as classes. But really, once you, if you're reading an article that has that type of implementation, then you should nearly stop reading straight away because it's of no use to you. It's too old, even though it's only 2 years ago. So there are many hooks that come with the React framework. We've seen one of them, use state. The second, probably most important one is use effect, which I'll talk about in a while. And there are others as well. And we'll look at some of the others as we work our way through the next few weeks. All of the hooks actually begin with the prefix use, and there's a reason for that. It turns out now that we can only use these hooks in a certain way within our component. And by prefixing the hooks with the prefix use, that allowed React to provide what are called linter rules. A linter is a tool that will analyze your JavaScript code. And so they're one of these things that are kind of in the background as well. And React uses a linter tool, and it uses the linter essentially to check your code to make sure that you haven't made any basic violations of your component implementation. And one violation might be that you are misusing the hooks that it provides. Now, what do I mean by misusing? Turns out, right, that there are two very simple rules, two simple rules. One really associated with using hooks, and it is that you can only invoke a hook function from what I'm calling the top level within a component here. To tell you, it would be probably easier to tell you where you shouldn't use a hook, and that's what I'm doing here. You should not invoke a hook function inside, let's say, an if statement, some sort of conditional statement, or inside any kind of loop construct. And really, if you try to, then the linter tool will actually report an error straight away. It'll actually report it, I think, when you try and do your transpilation. Okay, but so that's rule number 1, and it's really the only one, the only critical one. You cannot invoke hooks sort of other than at the very top level of a component. The second one, I suppose, would make sense. These hook functions, they are only functions at the end of the day, so you can call a function from anywhere, but it would obviously make no sense to call a hook function from from within some other function that had nothing to do with a React component. That goes without saying, I guess. Now, we've talked about one of the hooks, use state, and there's nothing else to use state other than what I've explained. The next hook that I want to talk about is the use effect hook. And you might remember when I was talking about JavaScript, I talked about this notion of side effects. It was just a general kind of programming idea. A side effect is A function, we would say, has a side effect if it tries to access something outside its scope, or if it tries to change something outside of its scope. We would say that function has a side effect. So this use effect hook actually is linked to that notion of side effects, because it turns out that sometimes components do actually need to have side effects and specific types of side effects. We can't avoid it, even though we like to try and minimize side effects from functions. So the use effect hook, what it lets us do is it lets a component perform side effects. That still doesn't tell us anything. What do we mean by side effect? Or can you give me examples of side effects? And the probably most common side effect that you might want a React component to have is to be able to talk to an external web API. And clearly, a web API is outside the scope of a component. So when we want a component to make a HTTP call to a web API, we actually put that code inside this use effect hook function call. Other kinds of ones, the other one on the other one I've mentioned there for by way of example is sometimes you might want a component to react to certain browser events, like if you resize the browser, maybe you want a component to change the way it displays, right? And clearly the resizing of the browser is something that's happening outside of the component's scope, but we do want the component to react to it. Now, the use effect function, it is a function, and this is a signature, takes two arguments, and you notice the first argument there is a callback, so hence use effect is a higher order function. And the callback is where we put the code that carries out the side effect that we want it to have. So in other words, the callback might make the web API call. The dependency array is a little bit tricky, but essentially the use effect hook doesn't execute every time a component re-renders, and you can control when it should or should not run by means of the dependency array. That's essentially what the role of the dependency array is. So again, I'll say that every time a component re-renders, the use effect hook doesn't necessarily execute. It may be skipped over, and you can control that by means of the dependency array. When I say the use effect hook doesn't execute, what I really mean is that the callback doesn't execute. A little bit more detail. So when does the use effect execute, i.e. when does the callback execute? Well, number one, it always executes when a component mounts. Remember I talked about a component mounting, unmounting there earlier on? So every time a component mounts or remounts, then the use effect callback is going to be executed. Number two, and this is where the dependency array comes in. The dependency array will essentially be an array of references to local variables declared within the component, or a state variable. So any kind of variable, whether it be local variable or a state variable, this tends to, the dependency array tends to refer to some, one, or possibly none of them. But what the role of the dependency array has is what I'm saying here. On every re-rendering, when a dependency variable has changed since the previous re-rendering, then the callback is executed in that case as well. So every time a component re-renders, what the use effect does is, the use effect function does is it checks the elements within this array, and if any of them, any of the values within those array variables, if any of the values has changed since the previous re-rendering, then the callback is executed. So it must actually keep a copy of the array between re-renderings, which it does. We don't care about how it does that, but it does it. In a lot of cases, really all you want is your use effect callback to execute on mount time. And so, and that'll be the majority of, in the majority of our cases as well. And so what you do is you actually just leave the dependency array as an empty array. You don't leave it out entirely, because that'll have a completely different effect. You just have an empty array there. So if you only want your use effect to run at mount time, then that's the trick in terms of the getting that behavior. Now, obviously I need some examples to demonstrate this use effect hook. So here's my little sample app. And so on the right, this is how the app will look. I get a list of my friends. And as I type into the text box, this list is going to be filtered. That's the way it's behaving. The list of friends is actually going to be coming from the random user web API that we came across there in week 1 or 2. That's the behavior. In terms of my React app design, this is what I came up with. Do not worry about, well, how did you come up with that? I'll explain how I come up with these hierarchies in a subsequent lecture. But there are 3 components, and I'm trying to explain what each component is responsible for. So this component here is responsible for rendering 1 friend. This component is responsible for rendering a list of friends. And this component is responsible for rendering the title, the text box, and it also manages the listing component, if you like. That's hence this relationship here. So it delegates the actual displaying of the friends to this component. And it passes down the list of friends that it wants displayed at any one time to this component. What this also does is it computes the friends that should be displayed, and it computes that based on what was entered in the text box and knowing what the full list of friends are. This is stateful, and the state is what is the current value of the text box. And secondly, it has two parts to its state. It's also storing the full list of friends as a state variable. Again, don't worry about how I came up with that, just kind of accept that. Okay. So let's see it working. If you grab the archive with this set of in this week's notes, the archive will contain the counter, and it will also contain this sample app. So I've downloaded the archive, and it's this is what you will get. So it has 3 folders. This is the one that we're interested in right now. And you do the usual thing. You import it into VS Code. You run npm install, and then you run npm start. It's a create React app. Sorry, okay. Okay, and so here's my list of friends, Maria. And as I type, then it filters them. That's the behavior. Let's look at the code, which is really all we're interested in. And the component that we're kind of most interested in is the one at the top, I guess, because it's stateful, and it's also the component that's making the web API call to get the full list of friends. And it also computes the matching list of friends, although that's not that interesting. It's just ordinary using the ordinary array filter, which you've seen before. Maybe if we take it from the bottom up, actually, if we look at the friend component first. Yeah, let's do that. So friend is passed in just a simple little object containing a person's name, email address, and some other stuff as well, I think. And, you know, just does an ordinary displays the actual friend. Yeah, I put in a console.log to help us with understanding the flow of execution. But other than that, the friend component is fairly standard. the friends list, or filtered friends list, sorry, that receives an array of friends that has been computed by the top component, but essentially it just gets an array of friend objects. And we've seen this kind of idea before. So it's mapping over the array of friends, and it's producing a friend component for each entry in the array. Okay, and it just then displays that array. Just displays that array. So nothing interesting there either, really. So the key one is this one. Sorry now. Well, the index.js, that's not too interesting. It's importing app.js, and app.js contains my top component. So let's walk through it a little bit. Two state variables. The first one is going to hold the current value of the text box. I need to know what that is, and I need to hold on to it. The second one is going to have the full list of friends that I will retrieve from the web API, from the random user web API. And here's really what we're interested in. Here's an example of using the use effect. And this use effect contains within it a web API call. Right? And we've seen this before. So it's talking to my random user, asking it for 10 user profiles, if you remember. And critically, when it gets a response back from the web API, it triggers a change in one of the state variables. Okay, changes this state variable up here. And of course, we know when that state variable changes, then my component re-renders. So let's not lose sight of that from earlier on. Moving on down here, this is the event handler that executes when I type something into the text box. And don't worry about this line for a second, that's just boilerplate. But what do I do when somebody types something into the text box? I change the state variable that is holding on to the current value of the text box, which again is going to cause my component to re-render. Here, I'm just computing the matching list of friends. I'm taking my full array of friends, which has been returned by the web API, and I'm filtering over them. And you can look at the detail here, but really all I'm doing is I'm picking out friends whose, I think, is it their last name contains whatever's contained within the text box. So that's just ordinary array filtering. And what's the top component displaying onto the screen? A header, and it delegates to filtered friends, passes down the array that has been computed just up here. Now, okay, go back to the use effect. I suppose what we're really interested in. Its dependency array is empty, which means that the use effect, its callback, and its callback is kind of from here down, right? That's the callback. Because it has an empty dependency array, it will only be executed, this use effect will only be executed at mount time. And because this component is at the very top of the hierarchy, that's essentially when means that it only gets executed when the user loads the app into the browser. And that would make sense. We only make the web API call at the very beginning. We don't need to make it again. Now, you might think that, okay, I've positioned the use effect here. So you might think the flow of execution would be when this component renders for the first time, this executes, then this executes, then this executes. Now, okay, it's an asynchronous call, but you'd imagine it executes next. And so you would imagine this console.log to appear in the developer tools. Then, well, this is only an assignment statement. And this is just some sort of computation that needs to be carried out. So just before I move on, it's really, really important that I initialize my friends array to an empty array. That's really important. If I initialize it to null, then that would mean when I try and filter over null, then I'm going to get an exception thrown. That's just by the way, but going back to flow of execution. So you'd imagine this console.log would execute first, and then I've got another console.log down here. And you'd expect that to appear next on the developer tools. And of course, as a result of re-rendering, then this is going to appear a number of times. However, that's not how it actually flows. And that's what I'm trying to get across on the, let's see. Yeah, here. This screenshot is showing you the console.logs that are appearing as I play with this app, right? And so notice the first console.log is coming from the component at the top. So this here is coming from, is coming from here. And then this happens. This is coming from the use effect hook. I had a console.log statement inside there. So it turns out that the use effect hook, even no matter where you position it physically within your component's code, it is not going to execute until the component has rendered for the first time. And I'm kind of proving that to myself and TE here by virtue of these console.log statements. Because this console.log appears first, that must mean that the component has already rendered before the use effect callback is actually invoked. Okay, the use effect is an asynchronous call, but it doesn't actually make that very first call until after the component has rendered for the first time. That must mean that when the component renders for the very first time, I don't have any list of friends yet. And that's why it's really important that you initialize your friends state variable to an empty array, because if the top component renders, that means it's going to try and filter something, and the something better be an empty array rather than null. So the use effect hook executes anyway. Now, eventually, because that's an asynchronous call, eventually the response comes back from the web API, and we saw that inside in the use effect callback, I triggered a state change to my array of friends. And because I trigger a state change, that's why we get this. The component re-renders all over again. Of course, now in this second re-rendering, I now have a full list of friends. I don't have anything entered in the text box yet, but I have a full list of friends. And when I filter that full list of friends, it still remains, so the list of matching friends is still my full list of friends. And that's what I pass down to the filtered friends component. And voila, my full list of friends are actually displayed. So I've gotten as far as here. But again, what you need to understand is the fact that, so what I'm trying to get across is that the fact that the use effect hook executes after the component has rendered for the first time. Then I type something into the text box. And of course, by typing something into the text box, I'm changing the other state variable within my friends app component, which causes that component to re-render. And that's why this console.log is appearing. Key message is this one up here. And I would expect and require you really to study these little apps, even though they seem fairly straightforward, to study them to fully understand that kind of flow of control between my component hierarchy and the effect of the use effect hook and the effect of state changes to the execution flow of the app. Let's pause for any questions, even though it might be quite difficult now to formulate a question, but I'll give you a chance anyway. No, okay. Now, I've decided to complicate it for a good reason. So I've got a version 2 of this app, and I'll show you what version 2 looks like first. Version 2 is implemented in this file here. So to actually get version 2 to work, all you've got to do is go into index.js and change this from app to app2. And of course, create React app does its thing. It retranspiles everything. Two things have changed now in version 2. I've got a reset button here, and when I click the reset button, I essentially want to make a new call to the random user web API to get 10 more friends. I don't bother holding on to the 10 previous friends. You could if you want to, but that just slightly complicates the implementation. So I've left that out of it. So every time I click reset here, you can see my list of my initial kind of list of friends is changing. That's the first thing. And the second thing is, if you look over here on the right, I'm in the browser's tab. I'm displaying the number of matching friends that are being displayed. So initially it's 10. And so if I type something to try and filter it out a little bit, okay, it's now reduced to 6. I've got 6 here, and I'm also displaying the number of matching friends over here. And this is another example of a side effect, because clearly the browser's tab area is outside of any component. So I've added in another side effect, and I've also added in some extra state. Anyway, that's the behavior of version 2 of this app. So from a UI, that's the change. Now, how does that impact on my components? And it's really only the top component that's being affected by this. It means I need to add another state variable because I need my component to know when the user has clicked the reset button, because clicking the reset button, has causes some change to happen and will cause what's displayed on the screen to change as well. So I need to add that state variable, and essentially the state variable representing the toggling of the button is just going to be a Boolean, and it just goes from true, false, true, false. And if it changes from true to false, then that means I want something to change in what's displayed on the screen. And even if it goes from false to true, then I want something to change as well. From a side effects point of view, i.e. from a user effects point of view, this app, this version 2, is going to have 2 effects. The one that we're already familiar with, which is making the API call, although we now are going to make an API call when the app mounts initially, and also when the user clicks the reset button. So that user effects dependency array is going to change. Initially, it was just an empty array. The second effect then is the changing of the browser's tab. So I'm going to implement that using the use effect hook. Okay, so there's no asynchronicity going on here, but it's still a side effect, and it's still something that we would implement using the use effect hook. I'm not sure, I'll just skim over the code, but you really need to look at it. I would strongly encourage you to look at the code for version 2 in order to ensure that you fully understand how these things play out now. So anyway, here's my third state variable. Here's my the use effect hook that we've already seen. No changes there except for here. So now that means that my API call is going to happen at mount time. Every use effect executes at mount time. So it's going to execute at mount time, but it's also going to execute whenever the reset variable changes, and reset is my state variable up here. And as we see down here, I think that state variable changes, that reset state variable changes, where did I put it? Oh yeah, I've actually buried it inside here, right? It's associated with the on-click handler, and I've actually put the code here within the JSX. So you can do that if you want. If the event handler is quite short, you can actually do that. I could have put this up as a separate function up here, but you can see what it's doing is it's changing it's essentially toggling the value of the reset state variable from false to true and so on. So that's what causes the reset to change. And whenever the reset changes, whenever the reset state variable changes, of course the component re-renders, but in this case, as part of that re-rendering, it's going to make another API call. And here is the second effect. This is the one that changes the browser's tab. Okay, this is very much old school JavaScript. This is how we can actually access the browser's tab. Again, I've scattered console.logs throughout this code for the purpose of understanding the flow of control. So I've got a console.log within each of my effects, and I've got a console.log for the actual kind of re-rendering of the component as well. And again, the idea is that you would open up the developer tools and see how they actually play out as you interact with the app. And I'm just going to skip over that because that kind of explains what happens when the component mounts. This is the Friends app component at the very top of the hierarchy now. This tells you what happens in English in terms of the flow, and that happens when the component mounts. This tells you what happens when the user enters something on the text box. This tells you what happens when the user clicks the reset button. But really, you'd have to play with it. Here, I'm showing you a screenshot to prove that these things happen in this particular order. And I'm not going to talk my way through this now. You really need to study this. I know I've said that a couple of times already to you, but to rationalize it for yourselves and make sense of this flow. I'll pause again for a second. No.
Hello.
Okay. So, okay.
Are you not at risk of getting into some sort of loop with this these things? I don't know what.
No. This kind of this is all goes back to the unidirectional data flow decision that the React team made. The opposite to unidirectional data flow is bidirectional data flow. And while unidirectional flow is slightly more difficult to get your head around, as I'm sure you'll appreciate from this, in other words, the initial learning curve is quite steep. But once you get the fundamentals, and I've covered the fundamentals now, it doesn't matter whether you have 10 state variables and 20 effects. The way they work is the exact same. So it's really, that's why I'm kind of stressing the importance of making sure that you understand how version 1 and version 2 of this app works, and you will need time to study it. But once you have a grasp of that, then really any kind of app, it's not going to be any more complex than essentially this app here, right? Once you have the fundamentals. I mean, arguably, yes, I suppose you're right. You're not going to finish up in a loop, but it is, initially, it's quite difficult to rationalize in your own head the flow of execution. But unfortunately, it's just something you're going to have to do. But once you have a grasp of that flow of execution, and you bring that forward, no matter how complex an app you have, and by complex, I mean no matter how steep its component hierarchy is, you will be able to rationalize the flow of execution in it as well. And also, I did make the point there earlier on that when you design a React app correctly, and I will come to it in a later lecture, it's only a small number of components will be stateful. And typically those ones are not necessarily, those ones are the ones that tend to have the use effect hook in them. So you won't have a lot of use effect hook and use state being used everywhere around the place. If you did, then you would need to take a step back and redesign. So it's only going to be a small number of components that is going to have this within them. That's not a very satisfactory, but that's life, I'm afraid. So study version 1 and version 2 of this app is the recurring message, really. Now, I've kind of ignored the fact, and I'm just bringing it back into the picture here. But sorry, if I go back to the previous slide, here we're just concentrating on the Friends app component. That's the one at the very top. Maybe I should just spend a little bit of time on my time. I'm not sure if it's going to help or not, but here I'm showing you, this is the flow that happens when the Friends app component mounts mounts. By mounting, kind of mean it actually changes the browser's DOM. So what happens? First of all, the component renders, right? None of the effects have executed so far. The component renders. So I don't have any friends. My friends array is empty. We don't see it when we actually, because it happens so quickly, we don't see that, but it does actually render with no friends being listed, and the text box appears okay. Then, as we've already mentioned, as I already mentioned, it's only after the component has rendered for the first time that your effects, your side effects, will execute. And so here's proof that the first side effect that executes is the one that caused the fetch call. And that's only because I physically put that before the other use effect hook in my code. So it makes a web API call. Now that's an asynchronous thing, so that takes time to execute. This is proving to me that the use effect hook that changes the browser tab, that executes. Now I have no friends so far, which means my matching list of friends is 0. So it is actually going to display 0 in the browser tab, although it happens so quickly we don't see anything. Now it stops at that stage, right? But of course, I've made a web API call, and eventually the web API call is going to come back with its response, which means the use effect hook is going to catch that response. And what does it do? It changes one of the state variables. It changes the friends state variable. Whenever you change a state variable, the component re-renders. And that's proven by this. I now have 10 friends in my friends array. This component computes the matching list of friends. I haven't entered anything into the text box yet. And so it displays my 10 friends. But because the list of matching friends, the size of my list of matching friends has changed, that means that this side effect executes this time. Because, can I just go back to the code for a second? Sorry. Just realized now I didn't stress one thing to you, which is, see this effect here? This use effect, here's its dependency array. Its dependency array is whatever is the length of the list of matching friends. Sorry, now I should have really highlighted that. That's slightly unusual, but I know that's it. So if the length of the matching list of matching friends changes, whenever that changes, I want this effect to execute. Okay. That is just this thing up here, this computer. Okay, whenever the length of the list of matching friends changes. So let's go back again. And let's pick up the story from here. So the effect has executed. This tab changing side effect, it executes here because the component is mounted, and a use effect always executes when a component mounts. So it executes at this stage here, and it displays 0 into the browser's tab. I said that eventually the web API comes back with its data. So my friends app component re-renders, updates. I have 10 friends now. It computes the number of matching friends, which is now 10. It was 0. So the length of my list of matching friends has changed, which is why the effect that changes the browser's tab executes. That's proven by this. So at this stage now, my app is displaying 10 friends, and all of this has happened. Let's suppose the next thing that happens is the user types something into the text box. That causes a state change to one of my state variables, which is why this happens. The component re-renders. In this, what is now third rendering of the friends app component, it's going to compute the list of matching friends, which is going to be less than what it was up here. It was 10 up here. It's going to be something less now. It could be the same, but let's assume it's going to be less. So that means that the length of my array of matching friends has changed, which is why this happens. Changes the browser's tab. The use effect that makes the API call doesn't execute at all. Okay, let's freeze it there. Then the user decides to click the reset button. And I'm not going to, well, let's stick it on. Clicking the reset button is another state change. Component re-renders. That means it re-executes all over again. This time, it does actually make another API call. In other words, the fetch side effect executes, because the fetch side effect is dependent on the reset state variable changing, and it has changed because the user clicked the reset button. That's why this happens. Eventually, the API comes back with data, which is why component re-renders again, computes the matching list of friends, which is going to be back up to 10. It was something less up here. It's going to be back up to 10, which is why the use effect that changes the browser tab executes. So that's my explanation of that. In this slide here, I'm going back to the earlier version now, the simpler version. Of course, every time the friends app component re-renders, its children re-render and its children's children re-render, and that's really all I'm showing you here. Right. I've left it out on the earlier slides because I didn't want to complicate it, but that's what I'm proving here. Right. Again, friends app component renders. I make a, sorry, let me check this. Oh yeah, the friends app component renders, which is the one at the top. It computes a matching list of friends. Doesn't have any, we haven't retrieved any data yet though, but we're essentially sending down an empty array down to my filtered friends component. And that's, it kind of stalls at that stage. Then the API call is made, decide that the use effect hook executes, comes back with its data, top component re-renders, computes the matching list of friends, which is why passes those lists of friends down to the filtered friends component. And then we get each of the friend component instances actually execute. I think in this one, I've restricted it to getting 6 friends from the web API rather than 10, because it just got too long. And again, when I start typing something into the text box, notice here, right, that obviously when I type something into the text box, some of these friends are no longer, should no longer be displayed in my matching list of friends. And if you look at them here, some of them are not appearing. So the friends that are appearing here that are not here, those friend components are unmounted. And some stuff goes on down here. Similar stuff goes on down here as well. We typed in S here, let's say. If I hit delete, then all of the friend components that do not appear here are actually going to reappear again, which means the components associated with them are remounted back onto the DOM. Now, in terms of re-rendering and data flow, you know, there's actually quite a lot now. That everything in the red kind of inside this red area here, all of this is what's taken care of by React for us. All we do is implement kind of event handlers. So when the user types into the text box, I change one of my state variables, and once the state variable changes, React does all of this. And I'm just elaborating here a little bit on, okay, it re-renders various components. Once it has gone right down through the component hierarchy and re-rendered every component. What it essentially does here, I'm kind of summarizing it here, what essentially does then React is it looks at the current DOM data structure and decides on the most efficient update that it should carry out on the DOM data structure in order to change what's displayed on the screen. That's what I'm kind of outlining here. Okay, there's two parts to it. I'm saying the React computes the updates required to the DOM. It hasn't changed the DOM yet, so we call this, React calls this the pre-commit phase. And once it has computed what changes it needs to make to the DOM, it then carries out those changes, which we call the commit phase. And having changed the DOM, then the browser kicks in and it repaints the screen. But so React does quite a lot behind the scenes in terms of all of this re-rendering and updating of the DOM for us. We don't really need to worry about this part down here. We obviously need to understand at least that this stuff here goes on though. So we've looked at the use state hook and we've looked at the use effect hook. They are by far and away the two most important hooks. We will have about 3 others to look at further down the line though. I want to go back to data flow. Now, it seems misleading, but there are actually 2 data flow patterns. One is called unidirectional data flow, which we've talked about. The other one has 2 names. One name I don't like because it kind of contradicts everything that I've taught you so far. The other data flow pattern is called inverse data flow. It also has this name called data down action up, which is a name I prefer. Now, when does this second data flow pattern apply to a React app? And it is in the following situation. Now, if you can kind of visualize, let's suppose you've got a stateful component, but the event that will cause that state to change is actually dictated by a subordinate component. In other words, one of its children or maybe grandchildren, but it's a component further down the hierarchy. So we've got a stateful component, but the changing of that component's state is actually determined by an event that is managed by a lower component down the hierarchy. That component further down the hierarchy needs to tell the stateful component that it needs to change its state. And how do we actually achieve this? And the short answer is, well, we implement the inverse data flow pattern or the data down action up pattern. And what it really means is, and I'm illustrating it now again with our Friends app, our Filtered Friends sample app. And I've redesigned this app as follows. I've decided to put the text box into a component of its own. Okay, that's this component over here. So this component's only responsibility is for displaying the text box and for reacting to the user entering something on the text box. But the reaction will need to be to essentially tell this component here, you need to change your state because the state is still up here. And there is a reason for that, which I won't go into now, but let's just accept it, right? The state variable is up here, but what caused the state to change is determined by this component here. And so the way it works is what the Friends app component will do is it will pass a function reference down to the search box, and the search box component will invoke that function whenever the event occurs. In other words, when the user types something into the text box. And that function that it invokes, what the function does is it will change the state. Okay. So that's what when we talk about data down, action up. Data down is really, passing data down. Action up means that the action is contained inside here, but it's actually invoked by this component down here. So the action is kind of in an upward direction. I'm not going to talk. So you have the sample code for this as well, and the sample code is this one over here, this one here. It has the exact same components except for this additional one, and it has a slightly different design, obviously. And again, as I said, don't worry about, well, how did you come up with the design? Just accept it for now. And I'm only going to show you excerpts because all of the stuff that's inside this component here is the exact same as before. I'm taking the simplest of my 2 sample apps now, and I don't have any reset button or any of that. So this component is pretty much the same as before, except for this additional little function that it does pass down to this component. But so I'm only going to show you excerpts from the code. The implementation I've kind of already outlined. So here's my friend's app component, and here's the little function here. This is the one that's going to be passed down to the search box component. And you can see all the function does is it performs the state change. But this function is passed down to my search box, as you can see here. And so this is the first time that we've seen a function being passed as a prop. Up to now, a prop, I've given the impression that a prop can only be data, but in fact it can be a function, and to complicate it even more, it could even be a component, and we will see that later on as well. So we're passing a function down to the search box, and inside in the search box, as you can see there in the bottom left, I have my text box, and the text box has its onChange handler, and here's the event handler associated with the user changing the text box, and inside in the event handler, I'm calling the function that was passed down to me. All I'm doing here, remember I mentioned that the event handler has access to an event object. And in many cases, you don't need to worry about that event object, but here the event object is actually useful to us because it actually allows us to get at the current contents of the text box. And that's what this expression is accessing there. This is not React code. This is just browser code. So the event object has a target property. The target in this case would be the text box, and I'm just getting the value of the text box. And I'm passing that as a parameter to the function that was passed down to me. So it's essentially calling the function up here. And the function then carries out the state change, and we get the re-rendering and all that stuff all over again. So that's this data down action up pattern, and it's very useful, and we'll see it quite a lot actually, and its use case I've already explained when you need to use it. Now, that summarizes everything that I talked about, and I'm kind of glad that I'm finished slightly early because I'm not actually finished. You might remember, I'll pause for a second, I suppose, even though it's very difficult now. I appreciate it's very difficult to kind of formulate questions based on what I've covered, because I do appreciate that what I've covered is pretty complicated. We've ramped up the level of complexity in this lecture. I appreciate that. I would say it for the umpteenth time, you really need to study sample app 1 and sample app 2 and play with it and put in other console.logs if it helps you to understand the flow of control. But I will give you a chance. I'm happy to go back and drill down a little bit deeper into any aspect of it if you wish. So I'll pause for a second to allow people to ask me any questions if they have. Okay. So component state, hooks, and data flow is what we've talked about. I want to go back to a topic that I wasn't able to cover in my previous lecture, which is something called Material UI. You've already used this. Material UI is a React third-party library that makes implementing user interfaces a little bit easier anyway, arguably, and it also enables us to implement more kind of elegant looking user interfaces, and ones that give a nice kind of user experience rather than implementing all of the JSX ourselves in a kind of a manual way. The Material UI library makes it a little bit easier for us. And where did this name Material UI come from? So Google did some research. Did I mention when they're around 20? I thought I had a date on that thing. I think it was on 2010, or it could have been a little bit earlier, where they essentially kind of stood back and looked at what was happening both in the web world and in the native app world, and looked at the kind of user interfaces that people were developing, and really things were kind of all over the shop because there were no kind of best practices or principles at the time. And so what they came up with was a design system, and it's really only a set of kind of recommendations, a design system for building what it would consider higher quality digital user interfaces. And really what they did was they looked at the kind of physical world, and they looked at how we represent design aspects of the physical world, and we represent those designs on pen and paper. And that has been something that has been practiced for decades. So there are a lot of good principles of design in terms of how we represent textures of materials and shadows and light, and reflection, and how we represent all of those kind of design aspects on pen and paper. They took all of the good principles associated with that world and applied it to the UI world, digital UI world. And they came up with a design, they came up with a set of principles and rules, really, and practices, and gave it this kind of label, a design system. Now, the upshot was that one of the kind of outputs of this design system is a set of what it calls building blocks. Okay, I'm calling them components there, but not to confuse it with the components in the context of React. It's just really a set of building blocks. And they have 5 categories of building blocks, and they're all things that we would be kind of familiar with. Like if you take number 4 there are obviously some core building blocks that you need in order to allow users to input stuff into a digital user interface. But as well, taking number 1, the material design, one of its core building blocks are associated with how you structure and organize content on a page, which is what it's calling the display building blocks. And so we have things like grids and lists and cards. You come across grids already with Frank. A list is fairly obvious what it is. Cards are another core building block when you're trying to structure content. And you saw from the 3rd lab from last week, I use the card construct to encapsulate a movie. Also, obviously, there are navigation building blocks like tabs and other components as well, and so on down, right? So there's these 5 categories of building blocks that it defined based on the research that it kind of did. And we will be using some of these, not all of them, some of them in our implementation of the Movies app. Now, this material design system, what Google were not trying to get us to do is to copy their particular set of principles. You could certainly adapt it. And by adapting, we mean you could define your own kind of theme. You could put your own theme using the material design principles as your starting point, and then theme it based on whatever kind of branding you want to have associated with your web app. And bear in mind now that this material design is also associated with Android development and iOS development. It's not just for web-based apps, it's also for native apps. But you can actually kind of adapt the core part of this material design system and put your own theming. And by theming, we really mean you may want to define your own color scheme. You may want to adapt the typography core principles that come with material design, and you can do that. We won't in our case, but you can. So, but there are by no means trying to force everybody to essentially copy Google. Now, where Material UI comes in then is Material UI brings us back to React, and it is a library of components, and these components are based on the material design system that I've been talking about. And so with this, in this Material UI library, you have components, and you've seen some of them already, like card and grid and other ones as well, typography, etc., etc. And we can, if we want to, I don't, but you can actually define, there is a default theme that comes with the Material UI library. And by theme, I mean a set of kind of a color scheme and a typography system, and you can adapt that, and that may be something some of you might like to do in the assignment, but it's not essential. It's mentioned in the assignment spec if you look back at it. Now, where I pick up the story though really is I use some of these components in the Movies app, and I don't tend to mess around too much with the core themes, but there is one aspect of the Material UI library that's slightly unusual, and it is how you actually kind of define your own CSS classes. Because at the end of the day, because in the context of the material design, in the context of a web user interface, it's going to mean CSS, right? And because we can adapt the default CSS associated with the various components, and we may need to tweak it, then the question arises with how do we define our own CSS classes using this Material UI third-party library? And the Material UI designers, they didn't follow the normal practice of just putting your own custom CSS classes into a CSS file. They actually allow us to implement our CSS as JavaScript, and then the JavaScript is converted to CSS for us. So the Material UI library follows this CSS in JS model, which other third-party libraries, JavaScript libraries, use as well. And it's really that's the only aspect of Material UI that I want to just explain to you. And I'm explaining it by means of a very simple example. So if I wasn't using Material UI and I wanted to define my own CSS class, and I wanted to apply that CSS class to a particular part of JSX, this is how I would do it. I would create my CSS file and I define my CSS class. We've all seen that before. In my React component, I just import the particular CSS file. And wherever I want to apply my CSS class, this is how I do it. And we've seen that already. Header here, by the way, is just a HTML file tag. But if I had one of my own components that I wanted to apply a CSS class to, then this is how we do it. We've seen that from the earlier labs. So that's using the plain CSS model. But if we want to use Material UI, we can't use the plain CSS model. We have to use the CSS in JavaScript model. And this is how you do it with Material UI anyway. If you were using another third-party library and it was following the CSS and JS model, then you'd have to see how that third-party library does it. But in the case of the Material UI library, you need to import this function called make styles. You can see here I'm importing it from the material, some part of the Material library. So it's a function, and you call this function and you pass to it a JavaScript object. This is a JavaScript object, and the JavaScript object is a JavaScript representation of your CSS. And so if you compare this with this, you can see they're very similar, but it is a JavaScript object. Okay. And in particular, for example, if you take background color here, which is a CSS attribute, you can't take that literal name and use it here. You actually have to change that attribute and use camel case. That's one of the differences between CSS and JSS and ordinary CSS. You have to use camel case, and you can see I'm using it here. And also for my, even though this is my custom class name, it has to follow the camel case style, whereas over here I use the hyphenated style. So anyway, you pass your custom CSS to this make style function, and what it returns is a function. This is actually a function. You then have to call that function. You don't have to pass it any arguments. I don't think there's ever any arguments that it takes. That function returns an object. Now that object is the key to getting at our CSS, because really what happens is this is converted into CSS in the background. This is kind of converted to this. We never see the results of the conversion, but it's available to us via this classes object here. You can call it anything, but we tend to call it classes. And you can see me using it down here. So classes.myHeader is clearly referring to this JavaScript object, but this JavaScript object has now been converted via this to a CSS class. So this is how I apply CSS, custom CSS, if I need to, within my React component when I'm using the Material UI library. And typically, you may want to tweak the CSS of Material UI components that you're using, like card and grid and whatever. Okay, so there's 3 steps in terms of using this CSS in JS model, and I'm giving you the simplest example over there, and you see lots of examples of it in the labs. And I've already mentioned the importance of camel casing all of the key value pairs within your CSS stroke JS object that you have. Right, that's it, I think. Yep. So another lab this week, and the lab just continues on. Sorry, no, I'm just going to kill that. Where's my camera? Yeah, that's it for this week. Fairly heavy going, I'll admit, but I think once we have use effect and use state, once you've got a grasp on that, then I'm pretty confident that you'll find the rest of the stuff a little bit easier to deal with. But I do think because it's really all about dynamics. Whenever you start introducing dynamics into any programming context, then that's when things start getting tricky. And the dynamics is really handled by just use effect and use state. There are no other aspects really to dynamics when it comes to JavaScript. So have a look over those 2 sample apps and then tackle the lab. And I guess I'll just see you on Thursday. And if you've got any questions which you may have formulated by then in relation to the apps, then I'm happy to try and explain them to you. All right, I'll leave it at that, and I'll talk to you again on Thursday. Thanks.